What we're going to be doing is looking at square areas. Okay, so we're going to take this idea of looking at area and basically how to find side length. So a very basic example before we even start taking notes so we know what this is I have this shape, and if I have an area that's like 25, and I was like, well, how did I get that area? Well, it's just the length times the width, or since it's a square, just like side length squared. And we would figure that out like, oh, like 5 times 5 is 25, okay? So we're basically going to take this number and figure out how to find the side lengths here. So I just want to illustrate this, guys. If I have an area of 1 square, I have the side length, which is 1, because 1 times 1 is 1. Vice versa, let's go ahead and look at this next one. I have a side length of 2, and I have an area of 4. So what do I need to do with this 4 in order to get the side length here? Same idea, I have a side length, an area of 9. This is 3, this is 3. And finally, one last thing, 16 is my area here, and I have a side length of 4. And how am I getting those? Well, the mathematical term is basically to take the square root. And what that is saying is I have an area of 16 or an unknown number, and when I take the square root, I'm going to find two numbers that are exactly the same to get that number. So for instance, if I have an area of 16, I take the square root of that, I would get two numbers that are exactly the same, are 4 and 4. Once again, guys, it's basically the side length of that square. It's a 1, 2, 3, 4. Okay? So let's continue to explore this idea. So it says find the area of the following shapes on the grid of a horizontal and vertical segment joining two dots for a unit of 1, or 1 unit. So for instance, what this is saying is, okay, let's try to figure out the area of all of this. Now there's several ways to do this. Some of us might view this and say, okay, I can just go ahead and count across. So I'm going to make these individual little squares here. And if we do that, we can count the area. I'm going to take out my highlighter really quickly. And in green, so this is an area of 1, 2, 3, 4, 5, 6, 7. And if I looked at this, guys, this is a triangle. And if we remember the area of a triangle, it's 1/2 base times the height will give me the area. So I have a base of 1 and a height of 1. So 1/2 of 1 times 1 is just 1/2. So this is going to have an area of 1/2. This is going to have an area of 1/2. So I'm going to have a total of 8 units squared. Okay, so I don't know if these are inches. I don't know if they're feet. So when we don't know, we just write units and we put a little square, the little 2 on the top to represent squared. Okay, let's go ahead now look at B. We're going to use that same concept here. There's multiple ways to count the area, but if I start here, I go on over, and then I start here, go on over, and just continuing to do this. We notice that we have an area of 1 right in the center, so I'm going to highlight that in green. And then I'm going to go ahead and figure out the area of these triangles. So right here, I have a base of 1, 2, and a height of 1. So this is 2, this is 1. If I use my formula, 1/2 base, which is 2, times 1. So 2 times 1 is 2, and half of 2 is 1. So it's telling me the area of these triangles, I have an area of 1. So each one of those is an area of 1. So I'm going to write that in black in there. So this is an area of 1, 1, 1, 1, and finally another 1. So this would give me a total of an area of 5 units squared. All right, let's go and look at this next one. This next one's the trickiest of the bunch because there's just a, ton of shapes here. So what we're going to do is we're going to basically chunk it up together. So we can get an area of here. Got a triangle right here. Another triangle right here. Let's see how I can see the next one. Got a square right here. Okay. Perfect. And let's go ahead and chunk out the rest of this now. Almost done. Okay, so now I'm going to have to do this now. So Now that I've done that, let's go ahead now and look at this in blue. This is a rectangle, so base times height. I have a base of 2 and a height of 1, 2, 3. So 2 times 3 is 6. Let's go ahead and look at this. I have a base of 1 and a height of 2 for an area of 2. This is a triangle, guys, and if this is my base and this is my height, I have a base of 1, 2, and a height of 1. Remember, 1/2 of 2 times 1. 2 times 1 is 2. And half of 2 is 1. So it's an area of 1, which would make this also an area of 1. This is base times height, so 1 times 1 is 1. 1 times 1 is 1. And then 2 times 1 is 2. Finally, I have these little triangles here. I have a, this would actually be 1/2, because I have a base right here of 1 and a height of here of 1. So that one's a little tricky to see, so let me go and show you. I have a base of 1 unit and a height of 1 unit. So if I did 1/2 of 1 times 1, this would give me 1/2 right here, which means this one is also 1/2. So when I add all these up together, which I'll do in pink, I have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me double check to make sure it's correct. 6, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. 15 units. So this is just to show you guys what is area. Okay, how do we figure out area? And I really want us to focus on this square right here. So basically what it's saying is I have an area of 5. What are two numbers that are exactly the same to get to 5? How would we even do that? That's what we're going to explore today. But before we do that, let's go ahead and use this. It says create a square ABCD using the line segment AB. Each vertex must be on a dot. After you create your square, write the slopes of each line. Remember, in a square, they all have 90-degree angles, which means I need the slopes to be perpendicular. Remember, guys, that's the opposite reciprocal. So just as a quick reminder, if I had a slope of 3/4, the perpendicular slope would be -4/3. So let's go ahead, and they need to be equal as well. So let's go ahead and look at this. I have a slope of down 1 and over 1, 2, 3, 4. So AB has a slope of -1/4. So which means I need to get to CD or BC, or let's go ahead and look at ABCD. Let's go look at AD really quickly. This will be the opposite reciprocal because it's going to be perpendicular. So the perpendicular to -1/4 would be +4/1. So starting here, I'd go up 1, 2, 3, 4, and over 1, and this would be D. So then when I go ahead and draw that line, I would go up 4/1. Next, I need a parallel line to this. So this is down 1/4. So I can go down 1/1, 2, 3, 4. And then finally, I can connect those dots, which would also have a slope of +4/1. So they're all equal. These are 90-degree angles. Opposite sides are parallel. Oops. So let's go ahead then and write this. This would then just give me, this is D, A, B, C, D. So A, B, CD would be right here, which would be -1/4, and this would be +4, or 4/1, either way. So let's go ahead and look at this now. It says create squares with an area of 2, 9, 18, and 25. Let's start with the two easier ones, okay? I'm going to start with 2 and 25. And what we need to do is create a square where both sides are equal and will multiply to 9. So that's easy enough, guys. What we're going to think of as these are called perfect squares. When I draw this, if we notice this, here we go right here, guys. I have a side length of 1, 2, 3, and another side length of 1, 2, 3. So if we're talking about the area of these squares, and I have a side length of 3 here and a side length of 3 here, 3 times 3 equals 9, okay? Similar now, guys, can you think of two numbers that are exactly the same that will multiply to 25? Well, hopefully we can think of that, and we get 5 times 5 is 25. So if I draw this one, now I'm going to have a side length of 1, 2, 3, 4, 5. Okay, so one more time, guys, looking over at here, I have 1, 2, 3, 4, 1, 2, 3, 4, 5. 5 right here. 5 times 5 is 25. So if I literally made these little squares like this, I would literally have 25 squares, okay? Now let's go ahead now and look at the tricky ones. These are non-perfect squares. This would be like 2 and 18. Now if you think about this, how am I able to figure out two side lengths that are exactly the same that multiply to 2 or 18? It's actually pretty, you can't. So what we're going to do then is create area of two triangles to form an area of 2 and an area of, what's it called, of 18. So let's look at this. If I looked at the area of a triangle and I want an area of 1. So if I put this like this like this, and this like this, 1/2 my base times my height, which I'll put in a little different color, should give me the area. So if I look at this, 1/2 my base, this is 2, and this is 1. So 1/2 of 2 times 1, 1/2 of 2 would give me 1. So we can agree that this has an area of 1. So let me go ahead and actually erase that. So I know that this triangle right here that I just made, using the formula 1/2 base times height, has an area of 1. Now I'm going to do the same exact thing over here and have another one like this. And this also has an area of 1. Oops. So I know now this has an area of 2. Now I want you to notice this. This is not a unit 1 by 1, okay? This is 1, this is 1, this is something else. So I'm going to give you a little hint right here. This is square root 2. I'll teach you shortly how I got that. But I just want you guys to realize that I have to use these triangles. And right here, these are called perfect squares. They make these nice, pretty squares. Where anytime it's not a nice, pretty number, you're going to have these funky looking curved diagonal squares, okay? So now let's go ahead and look at this. I'm going to take this 18, and I want two numbers that multiply to 18 to be the side length. Well, you can't do that. So what we're going to do now is come up with a triangle that has that multiplies, that when I find the area of two triangles, I can add them up to 18. So let's go ahead and look at this then. I'm going to create a first triangle that has an area of 9. So this would be 1/2 base times height. So I'm going to get a base of 3, a height of 3, 1, 2, 3, and then I'm going to go over 6 across on both of these, okay? So let me explain what I just did here while I create that. So this will come with practice, guys, but I want you to realize it's like, okay, I'm looking for two triangles that multiply to two triangles that will add up to 18. So that would be 9 and 9, okay? And I know 1/2 base times the height will give me, needs to equal 9. So this is 6, and 1/2 of 6 times 3 will give me 9. So this will give me 1/2 of 18, which will give me, one more time, 9. This is also 9, and 9 plus 9 is 18. If you're a little confused on how I got these triangles when they're, these triangles that added up to those numbers, we'll go over that shortly. But the main thing I want you guys to realize is perfect squares will make these nice, pretty, easy squares like 1, 4, 9, so on and so forth. But these ones that are not perfect squares will be kind of tilted like this. So what observation can you make about your square representation of area 9? We would say this is a perfect square. On the other hand, what observation can we make about these squares that represent this? We call them a non-perfect square. And when I look at those squares, they're basically crooked. They're looking like kind of like diamonds, something like that, okay? So let's go over now and actually how to solve these. So it says complete the following sentence statements and provide examples to support your statement. So it says a perfect square is created when we have two, not whole numbers, natural numbers that multiply to the area. So what are some examples of these? Perfect squares would look like this. 64. What are two numbers that are exactly the same that multiply to 64? This would be like 8 and 8. What about if I had an area of 100? What are two numbers that are exactly the same that multiply to 100? That would be 10 and 10. Now to find the area of a square given the side length, all we do is multiply the two sides together. And to make that even a little shorter, what we can do is square the side length. So if I have a square, let me go ahead and bring one up really quickly. If I have a square and it has a side length of 7, it says, what do I do to find the area? Well, you could just do 7 times 7 is 49. Or you can do 7 to the second power, 7 squared to get 49. Either way. Now to find the side length of a square, given the area, what we're going to do is, it's this brand new thing we're going to do is called find the square root. So let's say I have, let's go ahead and look at one we haven't looked at yet. We're going to do a few of these. What we're going to do is take the square root of the area. To get side length. Now really quickly guys, square root, you might not have seen this yet. Basically what it is, it's this symbol like this. And what it's saying is, what are two numbers that are exactly the same that multiply to the number on the inside? So for instance, let's go ahead and do 3 of them right now. If I have the square root of 81, if I have an area of 81, you would take the square root of 81 and realize that 9 times 9 is 81. So we would say the square root of 81 is 9. Okay? Vice versa, like we did up here, I can square the side length to go back to the area, just so you guys know. We can look at another one. If I have 121, the square root of 121 is 11. And finally, guys, if I looked at another one, let's just say 25, the square root of 25 is 5. Okay? So let's go ahead. Square and square roots are inverses of each other. So what I want you to think of this, it's like they're opposites. So what's the opposite of addition? It's subtraction. What's the opposite of multiplication? It's division. And what's the opposite of something getting squared? The opposite of that is taking the square root of that value. Okay? So they are inverses of each other. So it says list the first 12 perfect square numbers. So if I wanted to list the first 12 squared numbers, basically if I had 1 to the second power is 1, 2 to the second power is 4, 3 would be 9, and how I'm getting these is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, so on and so forth. So the square root, the 6 to the second power, 36. What do we got? 7 is 49, 8 is 64, 9 is 81, 10 is 100, 11 is 121, and 12 is 144. So it says list the perfect squares, guys. These are the perfect squares. It's basically saying if these are the areas, these are my side lengths. I would take the square root of these numbers to get to here, and I would square these numbers to get to down here. Okay? So let's go ahead now and look at this table. What it's saying is I have the area of these numbers. So basically I have the areas of these, and I need to find the side lengths. Okay? So really quickly, how do I get those? Remember, all I'm going to do is square root all of these numbers. So the square root of 1 is 1. Now this is a funky one. I cannot take the square root of 3. In fact, if you put that in your calculator, it'd be like 1.7 something 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 that goes on forever and ever. That's not precise. So what we're going to do is just leave this as the square root of 3. So what I'm trying to show you guys here is the square root of any variable is the same. If I have a variable, it's just an unknown number. Well, if I'm given the area, how do I find the side length? All I do is take the square root. So it would be the square root of x. Okay? Now on these, it's a little tricky. You would take the square root of the number and the square root of the variable. So square root of 16 is just 4, and two numbers that are exactly the same, which is the square root of that would just be that variable. So let me explain that really quickly. If you want to take the square root of x squared, x times x is x squared, right? So what two variables are exactly the same that multiply to x squared? It's just x. Okay, so my answer here would be 4x. Now what if the length of the side? Remember, if I'm given a square and I know what the length of these sides are, all I would need to do then is, I wrote these in the wrong spot, I just realized that. Let me take 1 second back. So these are my areas. All the work's correct, I just wrote the answer in the wrong spot. So right here, I'll take the square root of 1 to have 1, the square root of 3, which is 3, the square root of x, which is square root of x, and the square root of 16 is 4, and the square root of x squared is just x. Sorry, I wrote those in the wrong spot. Okay, so let's go back here now. If I'm given side length, what did I do to get here? What I did is I squared all these numbers. So it's basically saying, sorry, that should be the square root of 3. What do I need to do with this 2 in order to get the area? Well, if the side length is 2, we just do 2 times 2, or 2 to the second power, which is 4. Okay? Let's go ahead and do 20 before I do go to the square roots. So what it's saying, guys, is here, same idea. I have a side length of 20 and another side length of 20. So 20 times 20, or 20 to the second power, it's the same thing, is 400. Let's go ahead. Let me go ahead and shrink this down. And we'll look at the variable y, and then we'll jump back to that square root one, because that one's a tad tricky. If I have this square, and it says this is a side length of y, and this is a side length of y, what is y times y? We're going to go way back. Y to the first times y to the first. When I'm multiplying bases, I add their exponents to get y to the second power. Okay? So now let's go ahead and look at this one. If I had an area of 13, I took the square root of it, and this is a non-perfect square. I can't simplify this. So this is just saying this is the square root of 13, and this is the square root of 13. It would be an irrational number that goes on forever. So guys, when I multiply two numbers that are exactly the same, they are going to get rid of each other. They're going to get rid of the square root. So it's going to be just 13. That's going to be the area. Remember how I said they're inverses of each other? If I took 13 squared and I took it to the second power, these would cancel each other and you'd be left with just the 13. Once again, guys, we're going to explore that idea, and if it doesn't make sense, please write this question down and we'll go over it next time we have our Google Hangouts. Okay, so now let's go ahead and complete this table. I'm going to look at these values, and what we're going to do is I am going to give the area, and I'm going to show you how we do this. So first thing, this is the square root of 49, which is just 7. Now, I never, ever, ever want you guys to take the square root of decimal. What I want you to do is write this as a fraction. So this would then be 49 hundredths, which is 49 over 100. So what we would need to do is, if that's the area, I need to square root the numerator and the denominator. The square root of 49 is 7, and the square root of 100 is 10. So this would be 7/10. Now think about that. I know it's a little weird to think about that. If this is 7/10 and this is 7/10, and I said, what's the area? You would just do 7/10 times 7/10, multiply straight across to get 49 over 100. Now we're just going backwards by square rooting those, okay? So once again, now guys, you're going to hopefully see a pattern here. This is not 49 tenths, hundredths, thousandths, 10,000ths. So this would be 49 over 10,000. Remember, that's the area. So to find the side length, we square root both of these to get 7 over 100. Two numbers that are exactly the same that multiply to 49 are 7. Two numbers that are exactly the same that multiply to 10,000 is 100. All right. Let's go ahead and look at the next part. Move this over here. Okay, next part. Let's go ahead now. This is 49 hundredths, tens, hundreds, thousands, 10,000s, 100,000s, millions. So I literally have 49 over 1 million. Oops. And when I take the square root of both of those, this will give me 7 over, let's see, 1,000. And 1,000 times 1,000 is a million. So now what we're going to do is if I give you the side length to get from here to here, I just need to square these numbers. I need to square these. So this would be 8 times 8 is 64. 0.8 times 0.8, you guys can use a calculator on these, is 0.64. Let's see, 0.08 times 0.08 is 0.0008. And last one, 8 thousandths times 8 thousandths is 0.1234. There we go, is that value. Hopefully we start to see the pattern. Now let's really jump into the meat of this. This is what we're going to really be focusing on, and we're going to want you to be able to take the square roots of these numbers. So guys, I know that the square root of 225 is 15. Now, not everyone knows that, so how would we figure that out? So what we would do to figure that out is, make a factor tree. So I just want to think of two numbers that multiply to 225, okay? So if we think about that, what are the two possible numbers that multiply to 225? I know it ends in a 5, so this is what's called a factor tree. I'm going to break this down into all the prime numbers. This would be then 5 times, and whatever 225 divided by 5 is, which is 45. Okay? Now, this is prime, so I'm going to leave it alone. I'm going to multiply two numbers hereby. This would break down to 5 and 9. So 5 is prime, but now I think of two numbers that multiply to 9. This is 3 and 3. So now, guys, I'm only going to focus on the prime numbers. And I want you to realize what this is actually saying. This is saying that I have an area of 225. And I need to take the square root of this to find the side lengths. Well, to find the side lengths, one of the 5s is going to go right here. The other 5 goes right here. Okay, that took care of these. Now I look at the 3s. One of the 3s is going to go right here, while the other 3 goes right here. 5 times 5 is 15. 5 times 3 is 15, and the other 5 times 3 is 15. So what I basically do, guys, is I look for pairs to take out of the square roots. And what I notice here is, oh, okay, well, I have a pair of 5, so I take one out. That represents 1 for the side length. And I have 3 times 3, which is 9, and I have a pair, so I will take 1 3 out. So I want you to realize, guys, when people are saying, why are you only taking 1 out? Because we're looking at the side length. One's up here and one's down here. But when I'm looking at just the side length, I'm focusing on one of them, okay? So let's go ahead now and look at the next one. Same idea, guys. I know that the square root of 625 is 25. I don't expect all of you guys to know that, though. So what we would need to do is make a factor tree. Same idea. I have a square with an area of with 625. And what I need to do is make a factor tree to figure out what the side lengths are. So let's go ahead and do that together. Just move this over here really quick. So let's go ahead now. Let's just say you see it ends in 5. Two numbers that multiply to 625, and one of them's a 5, would be 5 and 125. Same idea. If you don't know what the two numbers that multiply to 25, you can say, oh, this would be 5 and 25. And break this one down to 5 and 5. Now, once again, I'm only looking at my prime numbers, and the reason why is 5 times 5 times 5 times 5 is 625. We don't pay attention to any of these numbers. So in green, you don't pay attention to any of those numbers now, because those numbers are these prime factors. It is 5 times 5 times 5 times 5 is 625, okay? So now let's go ahead and look at this. If you look at this, you're looking for pairs always on square roots. You're always looking at two numbers that are the same. This is a 5. Here's another one, and I'll actually do this in another color, orange, so you can see what I'm talking about. I have another one, 5. And 5 times 5 is 25, okay? So really quickly, that means I have 25 times 25 is 625. If you're curious, where did those go from? If I write these ones in blue right here, 1 5 went right here, the other 5 went right here. Then when I look at the orange, I have another one. 1 5 is right here, while another 5 is right here. 5 times 5 is 25. 5 times 5 is 25. So when I'm talking about just the side length, though, is 25. All right, so let's go ahead now and look at a bigger number. I actually have no idea what the square root of 2,500 is, okay? So what we're going to do here is begin by taking the square root of these. And I'm trying to think, what are two numbers that are exactly the same? Once again, I just want you to realize that this is a square that has an area of 2,500, and I'm trying to figure out those side lengths. So this I know is 100 times 25. I just can tell that because it's 25 times 100 will give me 2,500. I could look at this then to get 10 and 10, and 5 and 5. Now remember, guys, I want you to realize you can break down these tens down more, but we're always looking for pairs. And I have a pair, so I don't need to go any further. So I would take 110 right here and 110 right here. What if I look at this now? I have my 5. I put 1 5 right here, and I have 1 5 right here. And I say, what's the side length? You would multiply these numbers. Any two numbers that you pull out that are next to each other are going to be multiplied. So this is 10 times 5, which is 50. So the square root of 2,500 is 50. I want you to also realize, guys, that there's not just one way to solve this. There's multiple ways to solve this. So let's say I said, I noticed that this is 10 and 250. I then notice this is 2 and 5, and this is 2 and 125. I notice this is 5 and 25, and this is 5 and 5. So I basically made a factor tree, and I'm only looking at these factors. And I want to pull everything out, and we're looking for pairs, remember. I have one pair here, so I bring out a 2. I have another pair here, so I bring out a 5. And then I have another pair here, so I would bring out another 5. 2 times 5 is 10, times this 5 right here is 50. So it doesn't matter how we solve it. Either way works, okay? All right, so let's go ahead now and look at 324. I don't know two numbers that multiply to 324, but I know it ends up to be an even. So what we're going to do is just keep dividing this by 2 in numbers that we do know. So this would be 324 divided by 2, which would give me 2 and 162. Okay, so I just once again realized that this was an even number, so I divided by 2. I do this again, it's 2 and 81, and then I notice this is 9 and 9. And I'm always looking for pairs, and I'm only looking for these ones on the end. So then I notice, oh, look at this. I have a 2 and a 9, which gives me 18. Some of us might have noticed that, oh, these could break down to 3s and 3s. And remember, we're always looking for pairs. So I would still have my pair here. I had a pair of 3s, and I had a pair of 3s. So your 3 times 3 is 9. So that's why you don't have to go all the way down, okay? Okay, guys, I'm going to break this up, I'm going to go over this one now, and I'll go over the next one, and I'm going to have you try the others before we start the second video, okay? So when I look at this, this is a squared. Remember, this is the area, and I'm looking for two numbers that are exactly the same. In this instance, it's variables that multiply. So this would just be a times a. And remember, I'm looking for pairs. So what do I do with that variable? A little shortcut here, guys, is whenever you're dealing with variables and exponents, what you are going to do is you are going to divide the exponent by 2. Okay? 2 divided by 2 is 1, so your side length is a to the first power. Let's go ahead now and look at this one. When it's combined of variables and numbers, what you do is you kind of just separate them. This is the same thing as the square root of 4 times the square root of x squared. Okay? So what we would do is, what is the square root of 4? What are two numbers that are exactly the same that multiply to 4? And that would just be 2 and 2 are the two numbers. So my answer here is 2. Same idea, guys, here. Since it's a variable with an exponent, you're just going to divide this by 2. to get x. Okay? Because think about this, if I wrote this out in expanded form, x times x, you're looking for pairs, I have a pair. It's right here of x. Let's do one more together. You have the square root of 64 and the square root of b squared. Well, two numbers that are exactly the same are 8 times 8, and the square root of 8 times 8 is just 8. You're looking for your pair, you have it. The square root of b squared, remember you're looking for pairs, you have one, which is just b. So your answer here is 8b. Okay, let's go ahead and look at the next. So let's go ahead now and look at these ones. We're going to start this off by looking at this fraction right here, or excuse me, this decimal. You never, ever, 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 ever want to find the square root of a decimal. What you guys want to do is turn these into a fraction. So remember, this is your tens, hundreds, thousandths, 10,000ths. So it's 144 over 10,000. And it would look like this. Now, when it looks like this, what you can do is take the square root of the numerator and the square root of the denominator. So what the square root of 144 is, two numbers that are exactly the same that just multiply to 144 are 12, and two numbers that are exactly the same that multiply to 10,000 are 100. Last step, you want to see if you can reduce these. You can reduce them both by 2, which would give you 6 over 50. And then you double check again, you can reduce them again by 2 to get 3 over 25. All right, one more time, guys. If you remember what this is saying, you're always looking for pairs. Because this entire thing is in parentheses, this entire thing is being taken to the second power. And what we would basically do is these would essentially, they're inverses of each other. They would cancel, and your answer would just be a plus b. Another way to look at this, guys, is you're looking for pairs, and this is a plus b times a plus b. You're looking for pairs of a plus b. I have two a plus b's, so this would just give me a plus b. Okay. All right. Let's go ahead and wrap up here. It says Marissa says that the square root of 9a to the 4th power would simplify to 3a. Ryan disagrees and explains 3a times 3a equals 9a to the 2nd power, not 9a to the 4th power. As we already talked about this, guys, we would separate these into two different ones. We'd have the square root of 9 times the square root of a to the 4th power. Two numbers that are exactly the same are 3 times 3. So, hey, look, I found a pair, which is 3. Perfect. Now, if we look at this, this is a times a times a times a, and we're looking for pairs. I have one right here, which is a, and I have another pair right here. So I have a second a. And as we remember, a times a is a to the 2nd power. As a reminder, a shortcut to do this is whenever you're taking the square root of an exponent, you just divide it by 2. And 4 divided by 2 is 2. So Ryan's right. Okay, let's go and now look at this. Complete the square model, simplifying the square root of 9a to the 4th. It's just another way to see the same problem, guys. What are two numbers that multiply to 9? Well, 3 times 3. 3 times 3 is 9. Now let's look at this, guys. A to the 2nd power times a to the power of what will equal a to the 4th. And we remember that when we are multiplying bases, what do we do with their exponents? We add them. So 2 plus 2 is 4. So it would be 3a to the 2nd power here. One more time, 3 times 3 is 9. A to the 2nd times a to the 2nd is a to the 4th. All right, so let's go ahead now and look at this one. This one's a little different. I have the square root of 49 times the square root of x to the 6. Two numbers that are exactly the same that multiply to 49, 7 times 7. So the square root of square root of 49 is just 7. So we got that part taken care of. This is a 7, this is a 7. Now this one's a little different, guys. Let's look at this. Remember, this is x times x times x times x times x, and 1, 2, 3, 4 times x, and I'm looking for pairs. So I have one pair here, one goes right here, one goes right here. Let's go ahead and look at the second pair. One goes right here, one goes right here, and let's look at the third pair. One goes right here, and one goes right here. Remember, I'm looking for the side length, and 7x times x times x is just 7x to the third power. Do you have to write it out like this? No. In fact, what I do is I'm looking for groups of 2, so I divide by 2, and we get that 6 divided by 2 is 3, so 7x to the third power. All right, let's go ahead and simplify this now. The square root of 25x to the 10th, same idea. Let's take the square root of 225. Two numbers that are exactly the same that multiply to 25. That's just 5 times 5. And I'm always looking for pairs. I have that. So 5 times 5 is, the square root of 25 is just 5. Now let's go and look at that second part. So the last time, guys, you're going to see me write them out in expanded form. Remember, there's 10 x's in here. 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm looking for pairs. I have 1, 2, 3, 4, 5, which would give me then x to the 5th power. And a simpler way to do that is just divide this by 2. 10 divided by 2 is 5. And that's how we get the exponent. Okay? So let's go ahead now and look at this, guys. I'm going to go a little quicker on this one. On fractions, remember, this is saying 49 hundredths. And to find the square root of a fraction, just do the top and the bottom times the square root of x to the 12th. Now let's go ahead and look at these, guys. Two numbers that are exactly the same that multiply to 49 is 7. Two numbers that are exactly the same that multiply to 100 is 10. And to get the exponent, what I'm going to do is take this 12 divided by 2 to get x to the power of 6. So it'll give me a final answer of 7 over 10, x to the 6th power. Now, I look at this with variables. Same idea. A to the 8th times b to the 2nd. Let's start with the first one. I can separate these into two separate. I don't even need to here, guys. If I were to write these out, remember I have a area of a to the 8th, b to the 2nd, and I'm trying to figure out the side length. So for variables with exponents, I just divide these by 2 to get a to the power of 4 times b, a to the power of 4 times b. So my side length is just a to the power of 4 times b. Okay, it says, does 3 to the 2nd power plus 5 to the 2nd power equal 3 plus 8? So let's go and look at this, guys. If I had 3 plus 5, I misspoke, this would be 8. This would be 8, okay? So that means this would give me an area of 64. So let's go and look at this now. 3 times 3 is 9. Plus 5 times 5 is 25. When I add those up, I get 36, and the square root of 36 is 6. So does 6 equal 8? No, it does not. So those are not the same thing. They are not equivalent. All right, guys, so hopefully this makes sense. The key points of here is I want you to figure out a square root of a number. I want you to figure out a square root of a variable to a number, so like 10 or something. I want you to figure out what we're trying to figure out here is when we take a square root of a number, I'm giving you the area, and what we are trying to do is find side length. If any of these don't make sense, guys, please come to questions next time I see you. Okay? You guys have a fantastic day, and can't wait to see you guys on next digital meeting.